All right, let's talk about problem solving. Anytime you're faced with a problem, you're basically at a fork in the road, right? You've got one path that's, perfectly paved, but it's going to take a while. And then there's the other one, a shortcut right through the woods. So today, we're diving into exactly that, the perfect versus the practical. Okay, let me paint you a picture. Imagine you've lost your wallet in a huge, sprawling library. So what do? What's your first move? Are you going to be the person who starts at the front door and just meticulously searches every single shelf, row by row? I mean, you're guaranteed to find it eventually, but wow. Or do you kind of stop, jog your memory, and go, wait, I was in the history section, and head straight there first? See? One way is perfect, the other is practical. And that simple choice, it's pretty much at the core of how we tackle problems all the time. So first, let's go down that perfectly paved road, the one where you're checking every single shelf. In the world of engineering and, computer science, this is what they call the algorithmic approach. And the name of the game here is perfection, nothing less. And just look at how structured this whole thing is. This right here is the classic engineering design process. It is a super formal step-by-step method that, it leaves absolutely no stone unturned. You define the problem, you get all the data, you weigh every single option, it's methodical, it's thorough, and it's all designed to give you the absolute best solution possible.
Now, at the heart of this perfect path is something called an algorithm. The best way to think about it is like a recipe, you know? It's just a set of super precise instructions. If you follow them exactly, you're always going to get the same result. It's basically a repeatable, totally reliable instruction manual for getting things done.
But, okay, what happens when you just don't have the time to search the whole library? What if you need an answer, like, right now? And perfect is a luxury you just can't afford. Well, this is exactly where that second path comes into play, the practical shortcut. And this introduces us to a completely different way of thinking. This is the heuristic path. See, this approach, it's not about finding the perfect answer, not at all. It's about finding a good enough answer, and, this is the key part, finding it fast. So, what are we really talking about here? This is the very essence of a heuristic. It's a mental shortcut, a rule of thumb. If we go back to our library example, that little thought in your head, you know what? I'll just check where I was sitting first, that is a heuristic. It simplifies the whole problem, right? It goes from search the entire building to search the most likely spot. Now, it's not a guarantee, but it's super fast and, it's often really effective. And believe me, this isn't just some neat mental trick. This is a seriously powerful tool that professionals use every single day. Let's check out a fantastic real-world example from engineering to see what I mean. Okay, picture this. You're an engineer, you're on a job site, and your boss walks up, points to a giant pile of sand and says, hey, roughly how much sand is in that pile? What are you going to do? Counting every grain is obviously impossible. That's the perfect algorithmic way, and it's completely useless here. What you need is a practical shortcut. You need a heuristic. And this is where the magic happens. See, engineers know a rule of thumb about sand. They know it piles up in a really predictable way. That natural slope it forms, it's called the angle of repose. And for sand, it's basically a known constant. And that little fact, that constant, that's the heuristic. It's the key piece of practical knowledge that just unlocks a super quick solution. So look at how this all comes together. You don't need fancy, perfect measurements. You can literally just walk around the pile to get a rough estimate of the circumference. Then you combine that with your rule of thumb, that 32-degree angle, and boom, with a little bit of geometry, you've got a really workable answer. Is it perfect down to the last grain? No way. But is it good enough to make a decision? Absolutely. That right there is the power of the practical path. And it's not just in the physical world. This exact same kind of thinking pops up all over the digital world. Programmers and coders use these sorts of shortcuts constantly to solve some incredibly complex problems. So, on one side, you've got what's called the brute force approach. Think of it like trying every single key on a giant keychain. Sure, it'll work, eventually, but it could take forever. Then, on the other side, you've got a popular heuristic called the greedy approach. The rule of thumb here is super simple. Just make the best-looking choice right now, at this very step, without worrying about the whole big picture. It's a fast, efficient shortcut that more often than not gets you a really great result. So, when you boil it all down, what we're really talking about is a fundamental trade-off, isn't it? It's all about speed versus accuracy. And this chart here just lays it all out perfectly. If you go the algorithmic route, your goal is that optimal perfect solution. The risk? It might be way too slow or just totally impractical. But if you take the heuristic path, your goal is a fast, good enough solution. The risk there? Well, your answer might just be an approximation, or hey, it could even be a little flawed. Which, of course, brings us to the big question. So, which path should you choose? And the real answer is, well, it depends. And this is really the key takeaway from all of this. True expertise isn't about just mastering one perfect method. It's about building up this mental toolbox, one that's filled with both of these approaches, the algorithms and the heuristics. And then it's about developing the wisdom to look at a problem and just know which tool is the right one for the job. So I'll leave you with a final thought to chew on. In a world with, let's be honest, infinite problems but really finite time, what do you think is actually more valuable? Is it the relentless, painstaking search for that single, perfect answer? Or is it the practical, clever pursuit of a solution that's just good enough?